Okay, dear students, so welcome to our new chapter, students. Look at this photograph. What do you see here? Students, you will see a lot of musical instruments. See, this is a musical instrument, this is a musical instrument, this is a musical instrument, this, you know. So you can see different type of musical instruments on this photograph, students. Why we are seeing at these many type of musical instruments here? Because students, the next chapter which we are going to study here is called sound. It's called sound. It's a very important chapter, students, and a very interesting one as well. So students, let's start this chapter with full energy and full enthusiasm. So students, so the first important point here to see about sound is that sound is a form of energy, students. Sound is a form of energy. So students, by now we know about many forms of energy. Can you name a few of them? So students, there is kinetic energy, right? This kinetic energy. What is kinetic energy, students? Can you briefly tell me? If an object is moving, we say it has kinetic energy, students. Then there are other forms of energy, like, students, heat energy, right? So it's very obvious what is heat energy. Then electrical energy. Electrical energy, right, students? So you understand what is electrical energy. So there are different forms of energy, students. Similarly, sound is also a form of energy, right, students? And as you know, energy cannot be formed or destroyed, only its form can change. Now this is a powerful statement, and I'm sure students you are aware of this. You have studied about this in previous chapters of science or previous classes, that energy cannot be formed or it cannot be destroyed, only its form can be changed. Let me give you some examples. Look at this loudspeaker, students. We know that it produces sound, right, students? When you play it, it will produce sound. Now how it produces sound, students? We switch on electricity, right? So we supply electricity to the speakers and they produce sound. So students, what is happening here? That electricity, which is a form of energy, is being converted to sound energy. So in this example, electric energy is being converted to sound energy, right, students? Let me give you one more example. See, this is a very simple way of producing sound. You can clap, right? When we clap, sound is produced, isn't it? So what is happening here, students? See, if you keep clapping, you will be tired. You will be tired. So what happens here? That your muscular energy is actually transformed into sound energy. So students, you can see these are some examples in which energy is not being formed or not being destroyed, but it is being changed. Its form is being changed. In this case, from muscular to sound energy, and in this case, from electrical to sound energy. Okay, now we are moving to the main section in this chapter, that is called production and propagation of sound. So first of all, we need to understand the meaning of these two terms. What is the meaning of production of sound and what is the meaning of propagation of sound? It's very simple actually. Look at this photograph, students. You can see a teacher is reading out something. So obviously he is producing some sound. He is producing some sound, students, right? And this sound then travels to children. That's why children are able to listen to the sound, right, students? Now see, a similar thing happens here. See, this is a bell, students, and a bell is being hit like this. So what happens, students? The bell rings. So sound is produced, right? And then this sound travels far and wide. So even if you are standing far from the bell, you can listen the sound, right? So what is the production of sound? So see, production of sound is very clear, right? When this person is speaking, he is producing sound. So that is production of sound. When you are hitting this bell, sound is being produced. So this is production of sound. What is propagation of sound, students? When sound travels, we say it is propagating. That is propagation of sound. When sound travels, it is propagation of sound. So now we want to understand how this production and propagation of sound actually happens. So let us take the example of this bell, students. So when the bell is hit, what happens? That this bell starts vibrating like this. This bell actually starts vibrating like this. So this bell does vibrations, or we can say this bell does oscillations, or we can say that this bell does to and fro motion. Okay students, see, once you hit the bell, it actually moves ahead, it comes back, then it goes this way, and then it comes back, then again it goes ahead, comes back, goes this side, and then comes back, and it keeps doing this very quickly, right? So you may not notice it, but it actually happens, and such a motion is called vibration, or it is called oscillation, or it can be called to and fro motion. Let me give you one more example of to and fro motion, a very simple example. Okay, so look at this photograph, students. I'm sure you must be knowing who is this gentleman, right? So let's not focus on the gentleman, but let's see what he is doing. He's sitting on this swing, right, students? You know, in your childhood, in fact, you are still in your childhood, you must have sat on this swing, and you know, it moves like this, right? It moves like this. Such a motion is called vibration or oscillation or to and fro motion, right? These all terms are similar to each other. So similarly, once you hit the bell, vibrations happen. Now sound is actually produced due to this vibration. Let me tell you how. So now suppose this bell is vibrating here because you hit it, and you are standing here, and this is your ear. This is your ear. Okay students, you are standing here and this is your ear. Now what is there in between your ear and the bell? In between there will be air, students, right? And in air there are lots and lots of small molecules, or you can say lots and lots of small particles. Now see what happens when this bell does to and fro motion. You know, there will be some molecules of air at this place. So when this bell will do to and fro motion, it will collide with this molecule or many molecules which are present here. It will collide with many molecules which are present here, and due to these collisions, these molecules will also start doing similar type of to and fro motion. You understand, students? This bell is doing to and fro motion, so it will collide with molecules of air here, and they will also start doing to and fro motion. They will go ahead, come back, go on this side, then come back, and they'll keep doing this motion, students. Fine. Now what happens when these molecules start doing to and fro motion? They will collide with molecules ahead of them. These molecules, they'll collide with these molecules. Then these molecules also start doing to and fro motion. Now these molecules collide with molecules ahead of them, and they also start doing to and fro motion. When these molecules start colliding with molecules ahead of them, and they also start doing to and fro motion. So I hope, students, you are understanding what's going on. Now this molecule will collide with molecule ahead of it, and due to this it will also start doing to and fro motion. So due to this you can understand that this molecule, then this molecule, then this molecule, this molecule, then this, then this, then this, then this, then this, then this, all these molecules will start doing to and fro motion, right? All these molecules will start to and fro motion. And when the molecule of air near your eardrum, does to and fro motion, then you hear sound, students. Then you hear sound. You understand what is going on? This is doing to and fro motion, this bell, due to which these air molecules start doing to and fro motion. They collide with molecules ahead of them. They start doing to and fro motion, and this process keeps continuing. Finally, when the air molecule in front of your eardrum oscillates or does to and fro motion, you hear sound. You hear sound, students. You understand? So this is how sound is produced and propagated. So you can see sound was produced here by the bell, and it has propagated, it has traveled to you. So this is how it happens. So students, this bell here will be called source of sound because it is producing sound. And this air here, students, air, it will be called medium. This is an important term, students. It will be called medium. Why it is being called medium, students? Because sound is traveling through it. Sound is traveling through it. Traveling through air. Sound is traveling through air. So air is being called medium. So students, I can write down here. Sound is produced by vibrating objects. Sound is produced by vibrating objects. As you can see here, students, sound is being produced by this vibrating bell. So whenever sound is produced, in whatever situation, it is always produced by vibrating objects. I will give you more examples to clarify this point. Second important point which I can write here is sound is propagated by to and fro motion of particles of medium. You understand? Sound is propagated by to and fro motion of particles of medium. Here, what was the medium, students? Air. Okay, so students, I told you this point that sound is produced by vibrating objects. So let me give you more examples of this. So students, look at this. This is a bee. This is a bee, students. It makes humming sound. You must have heard to that, students. It makes a humming sound, students. So how it makes humming sound? See, students, you must have noticed that it has wings, and it actually vibrates its wings very fast. Its wings vibrate very fast like this, right? They move to and fro very fast like this. And when they move to and fro like this, they are actually producing sound. Right? So what happens? Suppose you are standing here with your ear, right? So when these wings vibrate, they collide with air molecules here, right? So these air molecules also start doing to and fro motion. Now these air molecules will collide with air molecules ahead of them, and they will also start doing to and fro motion. So similarly, all these molecules will start doing to and fro motion, students. Finally, when the molecule of air close to your ear will start doing to and fro motion, you will hear the sound, students, right? So once again, in this case, you can see that sound is being produced by a vibrating object, as I told you, right? And it is propagating to the medium by vibration of particles of medium. You understand? For example, students, let us take example of this loudspeaker, right? This is one of the very common things which produce sound, students. So students, if you play a loudspeaker at high volume, right? You can actually try this experiment. If you play a loudspeaker at high volume, and if you look at this cone, this is called cone of loudspeaker. If you look at this cone very carefully, you will notice that it vibrates, little bit. It moves to and fro. It moves ahead and back. It vibrates. So it produces sound by vibrating. When it vibrates, molecules here, molecules of air here, they also start vibrating. Then they collide with other molecules. They also start vibrating. And sound is propagated in the same manner as it happened here, students. Right, students? You can see this is a bird, students. When it flaps its wings, you hear a sound. Why, students? Because when it flaps its wings, it is actually vibrating it, right? So sound is being produced. Now what will happen when it vibrates? Then molecules of air, they will also vibrate after collision. So sound will be produced and propagated. Similar is the case whenever sound is produced. For example, let us take example of this guitar. So what happens, students, when guitar is played, these are the strings of guitar. You must have seen that, these strings are plucked, right? So they start vibrating. You can even see in this image, this string is actually vibrating, students, right? So this string vibrates, due to which sound is produced, right? When this string vibrates, then air molecules here, this vibrating string will collide with these air molecules, so they will also start vibrating. Now this air molecule will collide with molecules ahead, they will also start vibrating, and sound will propagate in this direction. The same will happen in this direction, so sound will propagate in this direction as well. You understand? Then students, we human beings can also produce sound, right? We speak. Right now I'm speaking to record this video, and you can hear my sound, students. So what is vibrating when we are speaking, students? See, when we are speaking, our lips, tongue, they all vibrate, students, to produce sound. Not only this, students, there's this portion in our neck. If you look carefully, we are not studying biology, so we'll not get into great detail. This portion in our neck, there's a pipe inside here. That pipe also vibrates, students, right? And that's how sound is produced. See, students, whenever there will be production of sound, there will be some object which will be vibrating, right? There will be some object which will be vibrating. Let me give you one more example and a small experiment which you can actually very easily do. So students, you can take a small box like this, a small box like this, and then this is a rubber band. You can tie a rubber band like this on this box, okay? And then if you pluck this rubber band like this, you will notice that it starts vibrating and you will hear a sound, students. Right? So why sound is being produced? Because this rubber band is vibrating. Right? So as I told you, sound is produced by a vibrating object. In all the cases, I've given you so many examples. In all the cases, something was vibrating and sound was being produced. So let me give you one more example, students. This example is of tuning fork. Now what is tuning fork, students? If you happen to go to laboratory, physics or science laboratory in your school, you will definitely see a small device like this, which is called tuning fork. It's a very simple device and it is actually used to do experiments. It is used to do experiments on sound. Okay, students. So when you also go to higher classes, I will tell you a lot of experiments which you can actually do with this tuning fork. But anyway, students, let me tell you a simple thing here based on tuning fork. If you take this tuning fork in your hand and if you hit this part of tuning fork softly to some other thing, we'll call that if you tap this part of tuning fork, that means if you hit this part of tuning fork softly with anything, maybe table, or any other soft thing, then it will produce sound, students. It will produce sound. Why it produces sound, students? Can you think why it must be producing sound? The reason is simple, students. When you hit it softly, these things, they start vibrating. And due to this, they produce sound, students. Right? And you know what happens here. When they start vibrating, they will collide with molecules close to them. Then they will collide to molecules close to them. And in that manner, sound will propagate, students. Right? But students, you will not be able to see the vibration here. Because what happens that these vibrations are very small and very fast, so you cannot see them. So let me write this down. Tuning fork vibrates on tapping it. So it produces sound. Fine. But the vibrations are very small and fast, so we cannot see them. So we cannot see these vibrations because they are very little bit and they are happening very fast. So students, here I just want to tell you some small experiments which you can do with this tuning fork to prove that it is actually vibrating, right? So let me tell you some experiments to prove vibrations of tuning fork. So the first experiment which I'm going to tell you here is, students, that you can take a vessel. In that vessel you can put some water. Okay, students. Now you take two tuning fork. So one tuning fork will be such that it is not vibrating, right? So if you have not tapped it, this is a tuning fork which you have not tapped. You dip it in water like this and you take another tuning fork which you have tapped. Okay, students. So you will see in this case that nothing happens. In this case, you will see that the water will be disturbed. You will see that the water here, it will be disturbed. So it proves that the tuning fork is vibrating, right? See, if the tuning fork is not vibrating, then if you put it inside, nothing will happen. But if water vibrates or water is disturbed around this tuning fork, what it means that this tuning fork is actually vibrating, right, students? Water is disturbed. So by doing this small experiment, you can prove that this tuning fork which is producing sound is actually vibrating. If you put this vibrating tuning fork in water, you will see disturbances in water. Water may even spill out a bit. Okay, students. Now let me tell you another experiment. So in this experiment, you can, hang a ball like this, a very light ball, for example, a table tennis ball, right? A very light ball, like a table tennis ball, right? So suppose we have two balls, two light balls hanging like this. Now what will happen, students, if you take a tuning fork which is not vibrating or not tapped, which has not been tapped, and if you touch it to the ball, and in another case you take another tuning fork like this, which is actually vibrating, what will happen? So this tuning fork also you are putting very close to the ball. Let me draw that. Yeah, like this. So in this case, when you put a non-vibrating tuning fork close to this light ball, nothing will happen, nothing will happen. But in this case, because this tuning fork is actually vibrating, though you are not able to see it, what will happen? It will vibrate and hit the ball, due to which this ball will move away. Move away. Right, students? So by doing this experiment also, you can prove that this tuning fork, which is actually producing sound, is actually vibrating. Right, students? So once again I repeat, whenever sound is produced, something is vibrating. So dear students, I have been telling you again and again that when sound is produced, they are vibrations, right? So now I'm going to tell you about an experiment which you can actually do to prove this thing. So we are going to see an experiment to prove that sound is accompanied by vibrations. Okay, and this is a very simple experiment, you can easily do it. So first of all, for that experiment, you need to take a box like this. It must be a hollow box. It must be a hollow box. So for example, you may take a food can or maybe a Coca-Cola can, but you must be careful that you need to remove this part, this plate, from the can on both the sides. So basically this can should be hollow, right? You should be able to see through it. You understand? If this portion will not be there and if this portion will not be there, you will be able to see through it, students. So that should be the case, right? Then you take a stretched balloon sheet, okay, and you tie it at one end like this. On top of it, you can stick a small mirror, right, students? So this is a very simple setup. You can do it and it will be a lot of fun doing this, right? Then what you need to do is, you need to locate a good clean wall, okay, in a dark room. You need to have a clean wall like this. Then there should be a small source of light somewhere here from which light will come. Okay, very simple. There should be a small source of light here from which light will come. There should be a clean wall here. Okay, now if you place the box here, with this plane mirror pointing towards wall, you will see a spot of light here. A spot of light here. Here, students. Why you will see a spot of light? Can you tell me that? It is very simple, students. You have studied about light in previous classes and very basic knowledge is required here. Can you tell me why will you see a spot of light? See, this is a source of light, so light will come from this source, it will hit this mirror and then it will be reflected. It will fall on the wall and that's why you will see a spot of light. Very simple, students, right? Now, students, you start speaking in front of this box, at normal volume, the way you talk to your friend, right? So in normal volume, you start speaking in front of this box. When you do that, you will see that the light spot will start dancing. It will start moving up and down, up and down. So let me write this down. So when you start speaking in front of box, spot of light on wall starts moving to and fro. It starts moving to and fro, up and down, students. Now why is that happening? Can you tell me? See, students, it's happening because when you speak, this balloon sheet here, that starts vibrating. Okay, right? See, when you speak, then molecules of air here, they start vibrating. Okay, they collide with molecules ahead, so they start vibrating. They collide with molecules ahead, so they start vibrating, and then these molecules collide with the balloon sheet, so the balloon sheet starts vibrating. Along with this balloon sheet, this mirror also starts vibrating, right, students? And when this mirror starts vibrating, this spot of light will start moving up and down, up and down. So you understand why this spot of light starts moving, right? So let me write this down, students. So when you speak, the mirror on the balloon sheet vibrates, causing the spot of light on wall to oscillate, students. Now this observation, this experiment proves that when sound is produced, vibrations are involved, right? See, why this this spot of light was actually vibrating. It was vibrating because when you speak, when you produce sound, this mirror was also vibrating, students. So this experiment proves that sound is accompanied by vibrations, right, students? So students, now we'll talk about medium in more detail, students, right? So by now we already understand that medium is the substance. Medium is a substance through which what? Through which what? Tell me, students. Through which sound travels. So medium is the substance through which sound travels. Right, students? For example, we have seen the example of bell, students, right? We have seen the example of bell, right? So when the bell is ringing, sound travels through air and reaches to us. So sound is traveling through air, so we called air as medium, students, right? So, you know, so air is medium here because sound is traveling through air, right? So generally air acts as medium for sound. Generally, if you are talking with your friend, you are speaking, but the sound is traveling through air. So this air is the medium, students. Now, let me tell you a very interesting point and a very important point as well, students, that medium of sound can be solid, liquid, or gas, students. What it means is that sound can travel in solids, liquids, and gases, students. See, it's a very important point, students, that sound can travel in all the three forms of matter, that is solid, liquids, and gas. Now let me explain all these three. So if we talk about gases, it is very clear to you, right? For example, air is a gas. Air is example of gas. So sound can travel through air. So we can clearly understand that sound can travel through gases. Now let me tell you about liquids. So students, look at these fishes. They are in water, students, and you know, some fishes do produce sound, you know, and another fish can listen to this sound. So in this case, you can see that sound is traveling through water, which is a liquid, you know. In fact, you can do more experiments, students. Suppose you are swimming in swimming pool, students, like this, you know. So this is you who is swimming in swimming pool. Now this is the bed of swimming pool, the floor of swimming pool, okay. Now if you drop a coin, you know, so this coin will hit the bed of swimming pool and a sound will be produced, right? And you will be able to hear that sound. You can do this experiment. You will be able to hear that sound. Now, how are you able to hear that sound? The sound is being produced here and it is traveling through water to you. So sound can travel even in liquid students, not only gases. Right? Now look at this photograph, students. Here I will explain you that sound can travel even through solids. See, students, this is a small toy which you must have played with in your childhood. See, there is a small cup here or a small hollow box here, and similarly a cup or a small hollow box here, and in the middle there is a rope. You must be able to see there is a thin rope here, students, or a thin thread here, students. Thread, right, which is actually a solid substance, right, students? Now if a person speaks slowly in front of this cup, the person here can listen to the sound. You know, if this lady speaks slowly in front of this cup, this lady will be able to hear the sound. Now how is that happening? So in this case, The sound here is traveling through this thread. It is traveling on this thread and reaching to this person. So in this case, sound is traveling through the thread, which is a solid. So you can see sound can travel through solid. I'm sure students that you would have played with this toy in your childhood and you are understanding what I'm saying. Anyways, let me give you one more example for solids. So this is again a very small experiment which you can do with your friends. So see, you can lie down on a table like this. This is basically a table, right? A wooden table, for example, which is very easily available in your classroom or even at your home. So you can lie down on the table like this with your ear touching the table, okay? And tell your friend to scratch the table here, or to knock the table here, so that a sound is produced. Now you will be able to hear that sound and you will clearly feel that this sound has actually traveled through this table. If your friend makes a knocking sound here, you will hear a sound here, that knocking sound here, and you will clearly feel that that sound has traveled through this wood, which happens to be solid. Sound can travel through solids. Or you can also do a similar experiment like this here. So see, this experiment you can do solo. You don't need any friend for this. So just hold a rod like this. One end of the rod should touch the ear. Now if you knock the rod here, a sound will be produced and you will hear that sound. That sound is actually traveling to you through this solid. Okay students. So sound can travel in gases, in solids, as well as in liquids. So the next point, students, regarding medium is that sound cannot travel without medium. Right? See, if you are standing and your friend is there, but if suppose there is vacuum in between, vacuum means there is nothing at all in between, students. Then even if you speak, this sound will not travel to your friend and your friend will not be able to hear the sound. Why, students? Because there is no medium. Sound cannot travel without medium. Let me give you one more example. Look at this photograph, students. You can see two astronauts in space, right? So in space, students, there is no air. I'm sure you must be knowing it, that in space there is vacuum, there is nothing, right? So if one astronaut tries to speak, the sound is not going to travel to the another astronaut because there is no medium there. So in space, it is not possible to talk. In space, not possible to talk. But can you tell me why it is so? Why sound cannot travel without medium? Why? What is the reason behind that? I'm sure students you must be able to think that we have already seen that if a person produces sound, there are vibrations, right? So the molecules of air close to the person start vibrating. Then this molecule collides with molecules ahead, so they also start vibrating. Then this collides with molecules ahead, they also start vibrating, right students? So this way molecules start vibrating like this and sound travels, okay? But if there is no medium, students, then obviously you can understand there is nothing here, so nothing is there to vibrate. There is nothing which can vibrate here, students, right? So it is not possible for sound to propagate.